With regard to the broad variety of flame retardants needed to fulfill the required technological function in the various matrices, this is a very ambitious question. There are different types of flame retardants, whereby pinfa represents the non-halogen phosphorus, inorganic and nitrogen flame retardants. Our so-called pinFRs represent a quite broad variation of chemical structures with variation in their intrinsic properties. Some of those properties are due to their technological function. In our product portfolio, we do not have substances of very high concern, and as pinfa, we are working continuously to improve our products with regard to function and safety. Also, in case of fire, means in the event when FRs have to do their work, it can be said that pinFRs do not increase the toxicity of the smoke. In some cases, pinFRs reduce smoke generation. Both effects contribute to the safety of phosphorus, inorganic and nitrogen flame retardants. Overall, we can say that our pinFRs do not represent an unacceptable risk to man or the environment, and if correctly handled within the scope of their intended use, they are considered being safe. And not to forget, flame retardants help to increase escape time in fires and thus save lives. Do flame retardants have a positive environmental history, you may ask? Flame retardants have gained scientific and public attention because of widespread findings of certain brominated but also chlorinated flame retardants in the environment, in water, air and soil or house dust, as well as in animals and humans. Pinfa represents the non-halogenated phosphorus, inorganic and nitrogen flame retardants. Many of these flame retardants were assessed by independent researchers and environmental agencies and were found to have an acceptable environmental and health profile. Many people are still not aware that better alternatives to legacy flame retardants exist and can be used.
Do flame retardant materials really make our buildings and transportation facilities safer? Flame retardants help to reduce the ignition of a material and thus help to reduce the number of fires. In addition, flame retardant also help to reduce the flame spread of materials in a case of fire. This provides people more time to escape from a building, or a train, bus, car or aeroplane. It also gives the fire brigade more time to arrive at the fire and to extinguish it, which is very important because fire often starts very slowly and then rapidly accelerate and spread.
Are there any risks related to the environment for the use of phosphorus, inorganic and nitrogen flame retardants? Based on the broad range of our chemical structures of pin flame retardants, their intrinsic properties vary and therefore their environmental profile is not homogeneous. In the European Union, chemicals are ranked by their inherent degree of being hazardous. Some pin flame retardants exhibit some endpoint-specific environmental hazards, but overall they exhibit a good environmental profile. A meaningful assessment of risk to the environment can only be made if the extent of exposure is known and compared to. The majority of their lifetime, flame retardants are embedded into a matrix, typically a polymer representing a product. At this stage, an exposure is rather unlikely and risks to the environment and to humans, if any, are considerably low.